Fine. Anyways, so the Powerball number has been. It doesn't need to be unique, right? It can be like the rest of the numbers, because the only thing we have to worry about, right, is that it's restricted from 1 to 26, right? And so that's all we do. We really we say Powerball number equals rand, some random number, mod it by 26, and then add a 1. So now it'll be, the Powerball number should be equal to some number between 1 and 26, right? So those are all the computer generated winning numbers, right? We don't have to worry about anything now. But we got to worry about the user. So the user is pretty easy. Well, at least getting his numbers are, right? We first create like 6 variables: choice 1, choice 2, choice 3, choice 4, choice 5. And then we have the Powerball choice, right? And when we say to the user to help them understand, we have to say, please enter 5 numbers. Please enter 5 numbers. Should probably say 5 unique numbers. Unique numbers, each between 1 and 69, and then a Powerball number, between 1 and 26, right? Pretty simple. And what we do is we have a cin, and the cin is just going to get the choice 1, then it's going to get choice 2, it's going to get choice 3, then choice 4 or 5, and then the Powerball choice, right? So what'll happen is we first need to check, because we have their numbers, right? But we need to actually check if they're correct numbers. We need to make sure that the user didn't just input some duplicates or input numbers that go out of bounds, right? So on the first one, for the first number, you can ignore this. This is all for simulation. But to check the first choice, all we do is we call our out of bounds function, right? So let's actually go back to our out of bounds function. Our out of bounds function needs to know 2 things. So we have our out of bounds function right here. It needs to know the choice and the range, right? So for choice 1, obviously the range should be from 1 to 69. So that's what we pass as the range. We have our choice. We pass in choice 1 as the choice that we are inspecting, right? And then we pass in 69 because that's the range. We want to make sure it doesn't go out of the range of 69. Now, if we look over at our function, when these are passed in, what should happen is that it says choice should now equal, let's say the user entered the numbers 1, 2, 3, 4, 5, right? Those were its choices for the lottery numbers, right? Now, if the choice, it's going to say for choice 1, it should be 1, right? Choice 1 would equal 1, and choice 2 would equal 2, and then choice 5 would equal 5, right? So for choice 1, when they enter choice 1, it's going to input 1 here, right? And the range should be 69 right here. And it's going to say if choice 1, which is 1, is less than 1, it's not though, because 1 is not less than 1. Or if choice 1, which is 1, is greater than 69, well, 1 is not greater than 69, so these will both be false, right? These will both be false. And then it'll say this will all be skipped, so this won't be ran, right? But let's say they entered -1, right? Well, if they enter -1, this would be true, right? Because -1 is less than 1, right? So that would be an issue. So that would return true. All right, this part, this is -1. -1's obviously not greater than range, which is 69. But, this part was. So we only needed one of these because this is an OR, right? This is OR. So we only needed one of these to be true. And so if it were true, it would see out -1 is out of bounds, and then it would exit the program, right? So, yes. So at this point, let's say they succeeded here, right? then obviously the next thing to do is just check the next one. We just check out of bounds for choice 2. Now, deal is, once, let's say out of choice 2 also succeeds, they also put a good number in for choice 2, but then we also have to check something else for choice 2, right? Choice 2, there is a possibility that choice 2 is a duplicate of choice 1, and if that's the case, we gotta basically ask for a new number. Aha, I just realized a mistake in this program. Yeah. Interesting. Okay. You know how I'm gonna actually do this? No, we'll just do it like that. Okay, so fine. I'll explain what I need to change in a minute. But basically, over out of bounds, we check for out of bounds. So let's say though, that the user actually entered, for the first number they entered 5, and for the second choice they also entered 5, right? So obviously that's an issue. But these will still both succeed, right? Out of bounds. Oh no, actually I was wrong. I don't have to change anything in the code. Never mind. No, yes I do. What am I talking about? Yeah, you do. Yeah. We'll have to change something in the code. So our out of bounds checks choice 1, which is 5. That's not out of bounds, so we're good. Out of bounds here also checks it. Still good because it's 5. Choice number 2 is also 5. But now we check over here. We say, is choice 2 equal to choice 1? And they are, right? 5 and 5. User entered 5, 5. You can't do that. No duplicates. So it says we see out, please do not enter a duplicate number for the first 5 choices. And then we say, please re-enter choice 2, right? And so we say cin choice 2. And at this point, they have the opportunity again to choose a number, right? Now what we can do, what should we call it? At this point, if they enter 5 again for some reason, let's just say they're being stubborn, they say, no, I want choice 2 to be equal 5. Well, our while loop is just going to keep checking if choice 2 equals choice 1. And if it still does, it'll just keep reprompting them, like, hey, please enter a new number, please enter a new number, until eventually they have to, right? They have to enter a number that's not equal to 5. Here's where the bug comes in. You gotta watch it, and I didn't even see this earlier when I last time did this. They could enter 70, right? They could enter, fine, I'll give you a number, and they enter something like 70 or 100, right? That's obviously out of bounds. But at this point, is there any way for my program, my code isn't going to check if it's out of bounds, right? After this point, it already checked earlier, right? If they enter a new number, there's nothing afterwards to check if that number, if the new number they entered is still within the bounds. So what I need to do is, after they enter a number within the while statement, I need to check again. So we're going to add out of bounds. And we're just going to put choice 2. And then 69. Okay. So now this should basically be more foolproof right there. That'll basically check it. It'll check, is choice 2 still within bounds after getting a new value for choice 2. If it is, fine. If it's not, exit the program, right? So now we can move on to choice 3. So choice 3, obviously same thing. We check if it's out of bounds, right? And then we have to make sure that it's not equal to the first 2 choices. If it is, then obviously we prompt for a new choice, right? And at this point, again, we need to make sure that their new value for choice 3 is also within bounds, right? Okay. And then same thing with choice 4. A lot of this is just copy and paste. You could probably simplify it a lot more, I think. But with an array, yeah, that's really the thing. With an array, this would have been a lot probably easier to do, and that's probably what I'm going to do next time. Maybe we could rebuild this with an array and make it a lot simpler. Yeah. So then we have while choice 4 is out of bounds. So all we're doing is checking choice 4 is out of bounds first. Then we have to make sure that it doesn't equal the first 3 other values. And of course we have to now check once they enter a new value, if they have to enter a new value for choice 4, we have to make sure that it's not out of bounds. Choice 5, we check if it's out of bounds, make sure it's not equal to the first 4 values. And of course, if it is, enter a new value and then check. We have to check if that value is out of bounds. And then out of bounds for the Powerball number, we check if it's out of bounds, but this time we changed the range. We changed the range to 69, right? We changed the to 26 because of course the Powerball number that they choose has to be between 1 and 26, not 1 and 69. So that's why we changed it there. Let me leave that out for a minute. Counter. Leave that out for a minute. Okay. So then at the very end, this part's kind of long, so I'm going to minimize that. At the very end, what we have is this big if statement, right? This if statement that says is found. Now if is found, let's actually scroll up. Let's see what is found does again. So all is found is doing right here is it takes a choice, right? A user choice, right? Takes the user's choice and it checks if it equals the first number, if it equals the second lottery number, the third lottery number, the fourth lottery number, or the fifth lottery number. If that choice equals any one of those numbers, then that user choice is a good choice, right? It's a winning choice, right? Now, a thing to keep in mind is that the Powerball, this is never going to represent the Powerball number. The Powerball number, we don't check it with the first 5 numbers because the Powerball number we just check that their Powerball choice equals the Powerball number. That's all we do. But for these, it is possible that their first choice, let's say this is choice 1 right here. This is, let's say, choice 1 that we're inspecting at the moment. It's possible that choice 1 ends up not equaling the first lottery number, but it could maybe equal the third lottery number over here. And so if this case is true, right? If this case is true for choice 1, then we want to say, hey, your first choice entered the equaled the third lottery number, right? And then maybe their second choice equaled the fifth lottery number, and their third choice equaled the first lottery number. Maybe and then their fourth choice equaled the second lottery number, and then their fifth choice equaled the fourth lottery number. And if that's the case, you can start to see they're all scrambled, right? They're all scrambled. The numbers are all in a different order, but each number equals one of the lottery numbers, which is good, right? That means you win, basically. So basically what this is going to check is it's going to check for one choice and check if that choice is a winning number, right? Is that choice that they made one of the winning numbers? If yes, we're going to return true, right? And so let's come back down here. We basically are saying if choice 1 is found within the winning numbers, and if choice 2 is also found within the winning numbers, if it is also a winning number, and then we're going to check if choice 3 is also a winning number, if choice 4 is also a winning number, and if choice 5 is a winning number, and if the Powerball choice that they made equals the Powerball number, right? If all those things happen, we have to use AND here, of course, because all of these things need to happen, right? They all need to happen simultaneously in order to win. If they all happen, then we say see out, you win, right? And then we're going to say see out your numbers were, and we'll put them out in the order that they said it. And then we also will say that we'll display what the winning numbers were, right? So we say see out, thanks for playing, right? Something like that. So let's actually try to run this. Let's actually try to see how this runs. so far. Okay, so I'm going to enter 5 unique numbers, each between 1 and 69, so let's actually try it. Let's say 34, 19, 21, 5, let's say 59, and then our Powerball number is going to be maybe 23. Okay, I didn't win because it would have said I won. I probably should have an else saying something like you lose. Better luck next time. Alright. So let's try that again. Now this time, let's actually try to make some mistakes, though, as the user. This is something you're going to have to count for a lot, right? One thing that's really big in coding is always trying to make sure that the user, you're trying to account for, I mean, that's what really bugs are, right? That's what bugs are. It's just the user did something that the program you made did not account for, right? You think in video games, right? Bugs. Anytime there's a bug going on, it's either because that the user did something which you aren't accounting for, right? A good game that has little bugs means that the programmers who made the game accounted for a lot of stuff that the user might do, right? Right. So that's it's just a really big thing, right? That's all what bugs are, right? So let's actually try to put some bad numbers in. Let's say something like, say 33, then we'll say 33 again. Then we'll say 79, maybe 26, and then we can say 59, and then our lottery number will be 6. Sorry, Powerball number. So the first 3 are obviously bad. The third one is bad because it's it's out of bounds, and then the third one is bad. Sorry, the second one is bad because it's a copy of the first one, right? So it's going to say, please do not enter duplicate numbers for the first 5 choices. Please re-enter choice 2, which means they want me to re-enter this choice, right? And I could say something like, okay, fine. You want a different number? I'll put in 70, right? If I put in 70, that's not good though. What'll happen is 70 is out of bounds and it kicks the program. You know, the reality of the situation, we probably don't want it like that. So actually, let's try to change that. Let's try to change that it doesn't do that instead. So let's see. In order to change that, we need to do this instead. We gotta say, I think what we could run is just continue. No, I wouldn't want to run continue. What I'd want to run yeah, we're gonna have to make this a boolean. So it would say something like return true. Okay. Yes, return true, and we're gonna make this a boolean type function. Now what'll happen with this function is if it's out of bounds, right? If it's out of bounds, it'll say return true. Basically saying, yes, their choice is out of bounds. Okay. So what can we do with this? So maybe right here, what we can do is instead we can move this right here. Let's copy that. And we would say something like this, or write that. Just like that. So what'll happen is they'll say if choice 1 equals choice 2, then or if it's out of bounds. Those are 2 potential issues that we both don't want to happen. So if it's out of bounds, or if it's, you know, if it's a duplicate number, let's fix that. Let's give the option to re-enter. So we can say, you know, please do not enter duplicate number. You can say, please do not enter, because now we have to count for two things. We can actually take the C out. We can get rid of the C out here. We can say, please do not enter a duplicate or out of bounds number for the first 5 choices. Okay. Let's copy that and just paste the same thing here. Make sure we're keeping it all uniform. Now what we can do is just do the exact same thing, right? Let's actually put spaces in here. Because you'll notice I named them after my variables. You don't want to do that because obviously your users never see your variables. So if you say something like choice 4, or if you just use variable names in your cout statements, they're not going to know what you're talking about. Now you can do it if it's a cout statement just for you, right? When I'm debugging a lot of times, right? When I'm debugging, sometimes I use cout statements to let me know what's going on. Or if your program crashes, sometimes your program can crash and you have no idea why, right? So, you don't even know when. Like, when did your program crash? You don't know at what point it crashed. So you put little cout statements as little markers. So, you know, if the cout statement does display, then you say, okay, well, I know it didn't crash here. It must have crashed later. So you put another cout statement later on in your code. And then you run it again. And you'll see if that cout statement runs. If it doesn't run, you say, okay, between this cout statement that doesn't run and between the other cout statement that does run, that's where the crash is, right? So you can obviously, when you're doing cout statements for yourself, you can write whatever you want. Anything that helps you. So let's see what we got going on. So basically now, all we want to do is just copy these and put them in the if statements. Oh my goodness. Should have done that. There we go. There we go. Oh, no. Let me copy this again. There we go. I'll make it option. Option 4 should be what we're checking. Yep, option 4. And of course, option 5. Just gotta make sure I put option 5 right there. Okay. What I should do is put this over here. There we go. Much more space. So yeah, I'm gonna get rid of this, of course. And we could actually do is get rid of all these right now. Because obviously our while statement, each time our while statement is already going to check if it's out of bounds. Our while statement checks every single time. After we get a new number, it's going to check if it equals all the other choices. And it's also going to check if that number is out of bounds now. So we don't have to check right here. So this is already simplifying our code a bit more, shortening it a bit more than it was before. Right? And for a while, this one here, we actually do have to create. We have to change this one a bit. This one needs to be a while loop now. And we say while choice 1 is out of bounds. We're going to say cin choice 1. Say please re-enter. And we could put out this error statement too. Why not? There we go. And the only reason, the reason we didn't do it before is because when they did make a mistake, like if they did go out of bounds on choice 1, we just exited the program. But honestly, that's kind of a lazy way of doing things. When you don't want to like, imagine if like the way Microsoft worked was that when you typed a word that wasn't spelled correctly, it just exited the program. It was like, okay, no, you got to give the user the opportunity to actually fix it. And they do, right? They do give you the opportunity to fix it. And so that's what we want to try to be like. We want to give you, you got to try to make sure that your program is usable. You don't want it to make it like a pain in the neck to use, because then obviously nobody would ever want to use it, right? So let's actually try to build this now. Okay, so we have 5 unique numbers. I think this should all work correctly if I did it correctly. But I guess we'll find out. So let's say 33, then we're going to say 79, and then we're going to say 25, 44, and then 6 for the Powerball number. Now, obviously, we have a duplicate number at 33. The second choice is a duplicate of the first choice. So they just need me to re-enter it. So if I say 70, if I enter 70, 70 is obviously out of bounds, right? I enter, it's going to say, hey, please do not enter duplicate or out of bounds number for the first 5 choices. So we have to re-enter it again. So if I keep doing something like let's say I enter 33 again, that's not going to work still. It's like, hey, you can't enter a duplicate. If I enter 100, if I enter negative 132, not going to work. Not going to work. I really am locked into this one, so I really have to say, okay. Now this is interesting. What if I made it 25? Okay. So this will actually, choice 4 wasn't a what's it called? It wasn't a duplicate. But if I make choice 2 a duplicate now, or sorry, if I make choice 2 the same as choice 4, then choice 4 will end up being a duplicate. And we'll see. And this is fine. You want to allow the user to do this, but they just got to realize, oh wow, actually. That's interesting. So it's like that. Choice 2. I'm a little confused, actually. Shouldn't have done that for 25. Why? Obviously, choice 2 did not equal choice 1, because that was 33. So it seems to me like, for some reason, this is running true. For some reason, this if statement, or this function right here, seems to be returning true. Now, I don't know if that's for sure, but one way I can check is by coming up here and putting a little cout statement within here, saying something like cout hello. If that happens, if I see hello, that means that's running true for some reason, which I'm not really sure why that would be running true though. Maybe I enter 25 again. 24? Even for 24, it says it's an issue. So see, we have an issue with our program already. Things like this never get old. So let's actually see what's going on. Let's build it again this time. But this time I've got that marker in there, that cout statement that says hello. And we're going to see what the issue is. So we have 33, 70, 79 it was, 25, 44, and 6. So obviously if we put in, if we re-enter 70, hello, okay. I said hello because obviously 70 is out of bounds. Let's say I enter 25. Huh. So our out of bounds is not running actually when we enter 25, which is good. That means our out of bounds function is working correctly. But the problem is I still don't understand why it would be doing this. Why is it saying that choice 2 still equals choice 1? No, what we could do is we could say a little cout statement to actually check if they are equal. Say cout choice 2 space choice 1, right? And then we can validate for ourselves if they're actually equal. Well, let's see what happens. Now we gotta exit this. You just gotta make sure you, sometimes people make the mistake that they leave their program running and then they try to build it. If you try to do that, it's gonna say like it can't build your program for some reason, and it won't really be super specific on why. And sometimes people like get all mixed up, like why isn't it just let me build? It's because your program is still running. So we'll say 333, 79. What was the other number? It was 25 and 44 and 6. So it's under 25. Very interesting. It didn't even output. Did not even output line number 91, which I'm a little confused about. Why wouldn't you output line 25, line 91? Huh. That is strange. Let's just see out hello. Make sure this is working. You know what it could be?
Before you put that loop in, it was exiting the first one. I don't know. I was just curious as to why it doesn't exit like that and move on.
Exit where?
The first loop,
Right
the
here.
choice one, yeah, because it's not exiting that loop.
Yeah, that's why I just realized. I'm wondering if it was actually in this loop. But that's very strange why it would even be in this loop. Because I think I realized something. Yes. I think I know what the issue was. Okay, so I think let's actually see if this was the issue though. I want to check it out. Well, I gotta actually. There we go. Run the task. So we'll say again 33, 79. Let's go 25, 44, 6. Interesting. Yes. Okay. Good. 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 So what was happening? Right. It kept looping in here, in this area. Now what's going on? Well, here's the problem. I'm not really sure why this happens, but right here, it's depending on this out of bounds, right? This while loop depends on this out of bounds. And what was happening is this out of bounds returns true. If it returns true, it's going to run our loop, right? Well, let's look at our function real quick. It says, and we can get rid of this real quick. If our choice was out of bounds, return true. But before, this wasn't here, right? So the question is, well, what if not? And sometimes you'd think that your program's smart enough to realize, just, you know, don't return true. Return null or false or whatever you want. But the problem with this is that it will return whatever it wants, and sometimes it'll just return true. And sometimes it'll just do continuously. I'm not really sure how that works exactly, but somehow it kept returning a true value or a positive value that meant true, or what could be equivalent to true. And because I didn't specify return false otherwise, right? So now it will, if this return true does not run, then this return false will run, right? And so because of that, I shouldn't run into the case where even when this condition, even when it's not out of bounds, right? It shouldn't be returning true. It should be returning false, right? So that's always why you got to make sure that you have a and I'm surprised that actually when you build it, usually when you build it, it doesn't like it'll tell you if you've done that. It'll tell you like, hey, you don't have a ultimate return value. Ultimate return value means if all else fails, right? If this fails, I should be able to like, what should I return? You should return false, right? If you have a lot of if statements that return each one return something, you need to have an else statement that, if all the other ones fail, it returns something, right? So that was what was basically going on there. Now we can get rid of these two things. Okay, now let's try it. Error, where? Oh, program's still running. So my program's still running. It says you don't have permission to write to a read-only file. And the reason it's read-only at the moment is because it's currently running. How can you don't want to be editing a project that's currently running, right? So we have to close it. All right, let's enter a bunch of values. Oh no, sorry, I actually have to rebuild it. Okay, so then please enter 5 unique numbers. Let's do them again. 33, 79, 25, 44, and then of course 6. Please enter choice 2. Right, we got to re-enter it. So let's say I entered 70. It's going to say, hey, re-enter 70 is too big. Then we're going to enter 25. 25 is good now. Now 79 is an issue. 79 is an issue because it's out of bounds, of course. So we have to re-enter it. Let's enter it to be just 40. Now choice 4. Let's increase this, right? Choice 4 is an issue because choice 4 is 25, and if you know, right, choice 2 also equals 25 now. Maybe one thing we could do is every time we change a value, right, we output what our new set of numbers looks like, right? That's something you could do so the user can always see clearly what's going on. So let's see though that we re-enter it. Let's re-enter it. And we'll say something like 26. All right, better luck next time. This says it means we didn't win. And what we can do next time, because we're about out of time right now. Next time, what we can do is we can try to rebuild this program using an array instead, right? We can make it a lot simpler, a lot more compact, because obviously you can see a lot of this is just kind of the same thing over and over again. And whenever you see that, that means it can be simplified much further. So yeah. Any questions on any of this so far?
Yeah, would you be able to send a copy of this one to us?
Yeah, for sure, for
The
sure.
way that it's written right now?
Yeah.
Okay, cool.
Let me I'll upload it. You know what? You know where the Canvas videos are?
Yeah.
So I'll when I upload this one and I put the link for this one, right? I'll put the code for it also right below it, right?
Okay, cool.
Very good. Okay. Sounds good. All right, I'll stop sharing. Any other questions?
I had a question just about was our professor was she supposed to upload like videos for any of the lessons, or is that not
Oh,
happening?
has she not been doing it?
I don't know. I haven't been able to watch any videos, or I haven't seen any videos
Let me
of
check.
our professor, and
They're there like when you go through the modules.
but they don't work, right? Or they don't work for you, or they don't work for me. I don't know if they work for you.
Oh, yeah, they work for me.
Yeah, it says it's disabled for some reason.
Gotcha.
Oh, yeah, I think I know what it is. Sometimes she probably may be disabled. Let me see. It's models. Yeah, chapter 4. I guess these are where the videos. Yeah, these are where the videos would be. It says disabled when you get here.
Yeah.
Uh-huh. It could be for some reason she hasn't given you permission to view it. Which I don't know how that would happen. But you might just want to check with her because and this is why all these professors should not be using something like I don't even know what this program is. Panopto. It's because they got some stupid deal with like some company and they have to use Panopto. Yeah. I don't know. I would let her know. Tell her that like, hey, I haven't been able to view the things lately, and so that way, because she has been making them.
Okay.
Yeah. But I
I
didn't
mean,
even.
whatever. Like, I don't know. Are they helpful, Isaac? You think they're helpful? Should I
Yeah.
waste my time on it? Okay.
I mean, you can also just review the book.
Yeah.
Well, see,
Let me say it that way.
that's what I was asking is because I mean, that's all I've been doing, just going through the book, just very, very meticulously, and like,
Yeah.
so
It's kind of the same thing. I mean, it depends on how you want to do it. If you want to listen to video or you want to do the book, like whatever your preference is.
Yeah.
Right.
I think both are useful, but
Yeah. Yeah. No. Yeah. For sure. For sure. Especially for like if you're going to a test review, definitely read the book. Right.
Yeah, reading the book is much faster. The
Yeah.
videos take long.
Yeah. I feel like if you read the book, you probably never have to listen to the videos, anyways.
that's kind of what I'm at with it. I'll email her though just to see if there's a fix because I don't know, maybe somebody else is going through that same issue.
Right.
She
Right. No, I
already has the
imagine.
fix.
Yeah. Thanks for letting me know. Yeah. All right. Anything else?
Yeah, are you gonna upload the test review from the other day?
Yes. Yeah. I have to do that.
Yeah, cool.
Yeah. No problem.
Thank you.
All right. All right. Well, I'll see you guys then on I guess what Sunday.
Yep, sounds good. Have a good one.
You too.
Yeah.
Oh, still recording.